Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. In this podcast, I talk to various people from different parts of Microchip to understand more about what the company is doing and the products it offers. And today I'm welcoming Thomas Souche onto the podcast. Thomas is Technical Product Marketing Manager at Microchip. Welcome to the podcast, Thomas.
Hello, Mike.
It's great to have you on the podcast. You're Technical Product Marketing Manager. Can you tell me a little bit about your role and what you do at Microchip, please?
Yeah, so actually technical product marketing means a lot of things. So I'm part first of the HMID business unit. It's the Human Machine Interface division. My role is about to define the product of the HMID for the automotive application, and that's mainly the maXTouch product line. And maXTouch is a touchscreen controller.
So what you're doing is you're helping people create touch controls. So can you sort of give us an overview of some of the different ways people can implement touch control and talk a little bit about what you offer in your division?
Yeah, so touch is obviously using your finger to interact with a screen or surfaces, and there was different way to do it in the past with different technology. It was optical or resistive technology. What we are doing here is really about capacitive touch sensing over touchscreen or smart surface.
And so that's capacitive rather than, resistive touch was one of the earlier technologies. So can you give me some idea of what the benefits of capacitive touch are, please?
Sure. So if you remember, if we start compare with resistive, for instance, maybe some of the people of the listener would think about devices that was introduced quite so many years ago. So touchscreen was there on resistive. You had basically two sheets that are contacting to each other. So one of the main drawback of the resistive, it was not a real multi-touch system. So you can use it only with one finger. And also due to the construction and of the sensor you have to put on top of the display, then you tend to have poor optical quality. So we used to talk about a milky aspect and reduce the brightness and the vivid color. And this is exactly what you can avoid when using capacitive touch, is that you can have still very good optical quality for your display, as well as a full multi-touch support.
So, I mean, that sounds great. It sounds what everybody wants, but as I understand it, it's actually quite hard to implement capacitive touch, isn't it? What are the challenges around implementing this technology?
Yes, so nowadays it starts to be more easier than before. But one of the key challenges is that the fact that it's capacitive touch sensing is indeed you are measuring very small change in capacity. So in the range of a picofarad, that's basically the parasitic capacity of your finger coming onto a touch sensor. And by doing so you of course prone to a lot of disturbance on also electromagnetic noises. This is one of the key challenges. But also, since you're relying on the conductivity of the human body, you also any conductive element like water could also be a challenge for doing a proper measurement and reporting a reliable touch.
Wow, so it sounds like it's quite tricky, but I know Microchip have got a lot of products. Can you talk about some of the products you've got and how they help engineers overcome some of these challenges?
You're right, Mike. Microchip has actually maybe a unique position and portfolio for addressing this type of application and when you want to do touch interfaces. And there's plenty of different way of doing touch interfaces. You can want to implement, starting from small discrete buttons through slider or capacitive wheels up to touch screen and very large touch screens. So I'm particularly taking care of what is related to touch screens. And for this, so we are proposing very bright range of touchscreen controller, and they're all called the maXTouch. This is a technology, maXTouch, that indeed is able to provide to designer who wants to build a touchscreen interface, or a capacitive touchscreen, a solution that will be easy to implement and still very reliable, and being able to cope with the challenge that we just discussed before.
And so to implement a maXTouch solution, I mean, what would a designer need? You know, is it just a component from you and a software library, or how does it work?
Yeah, it's a little bit more than a pure microcontroller. So what do you need to do a touchscreen? So one key element is the touch sensor, but it's a passive element. And that's usually is an element that is between the front panel, so that can be made of glass or of plastic, and that is sitting on top of the display. Sometimes nowadays it also get integrated in the display. So you have basically the front panel, the touch sensor, the display are the key element. And for the touch functionality, then this touch sensor is connected to the touchscreen controller. And the function of the touchscreen controller is basically to send stimuli to the touch sensor and to sample always this response of the touch sensor, which is passive element. And from this, do this capacitive measurement and apply a lot of different techniques of noise avoidance, noise filtering, to finally process and report the touch coordinates of the different fingers that are on this touch sensor.
So that's great. And then is there something that Microchip offers to help people build elements on the screen? So, you know, rather than just being told where the screen's being touched, does Microchip offer libraries that, for example, create sliders and things like that?
Yeah, that's the case for the solution that are using microcontroller with embedded touch library to build indeed this button or touch wheel. And for the touchscreen controllers, the maXTouch product, we are even delivering a full solution with a pre-programmed firmware. So our customer can directly receive the hardware and the firmware that is programmed inside, and just need to configure the right parameter to fit their needs. So it starts with the size of the screen, the number of touch channels that are used, but go down in more, you still have a lot of flexibility to adapt to your final application.
That's great, Thomas. I mean, it sounds like you're doing a lot to make it easier. You know, you mentioned the customers who use it. Can you tell me a little bit more about the applications and some of the main places where people are using this maXTouch technology?
So maXTouch originally was designed for in the early days for consumer application, but now all the design are focusing on two main segment, I would say, of the market. Is one is the automotive application, and obviously you see in cars always more displays, not only for the infotainment display, but for also passenger and different application, and they are getting bigger. So that's automotive is one key target application, but then you have also a lot of industrial application and medical, as well as home appliances. That's just to give you some example of where you find touchscreen. But basically, as soon as you have a display, you most of the time find also a touch interface for it.
That's great, Thomas. I mean, that's quite a broad range of different applications. I mean, some of them bring like quite specific requirements. Are there any particular challenging requirements you see in some of these application areas?
Yeah, definitely. So each application is a bit different. If you take, for instance, in the home appliance world, it's very important that you can cope with moisture coming onto the screen and that you don't trigger fraudsters. You want also to have a very safe interface to avoid any issue with your appliance, specifically in cooking application, for instance. So here, if you can support functional safety standards, and that's what we are doing with the maXTouch, it's a real benefit. For instance, in automotive or on e-bike, small computer module, you would like to be able to support fit gloves, for instance, which is could be a challenge for capacitive touchscreen controller. With maXTouch, this is exactly what we offer: is the ability to support fit glove, to support moisture, to have support for functional safety. Thus, without talking about all the reliability against different type of source of noise.
That's great. And I mean, obviously, you're using a lot of applications already. I mean, what do you see as the trends going forward, Thomas? Do you see anything driving more and more touch, or do you see it going in a particular direction?
Yeah, I would say that basically the trend continues and develop even more, is that touch screens enable customer and user to build modern and intuitive interface to the user that the user are really familiar with, because everyone has a smartphone and knows how to operate with a touchscreen interface. And now it applies to all aspects of our life. If it's in the car, if it's at home, or even if it's at work. So this is definitely the screen as the touchscreen has been proven as the right approach to interact. What we see is that they tend to get always bigger. Specific for in the automotive space, you start to have larger screen sometimes that goes from one pillar to the other. What is important for the car maker is the ability to propose a very good, bright, and with vivid color displays. And therefore, we see trends also for combining the touch with new display technology like the OLED technology.
And does the maXTouch technology, does that work equally well with these new display technologies and with the very large displays? Is that already designed in, or does that introduce new challenges?
Yeah. There's twofold in your question. Yes, so our product has always started from more than 10 years ago. We were targeting small screen in the 5-inch range. Now we can support screen that goes beyond the 30 inches. So definitely we already set up our product portfolio to be able to support always high screen. Now, if we talk to one of the trends I was just mentioning about OLED, here indeed what is really key is the ability to face this new challenge of the touch sensor being very close to the pixel of the OLED display. So very prone here to the coupling the noise of the display, or having electrodes, so touch electrode that are having a very high load to ground. Mm-hmm. And our latest generation of product are able to cope with these main challenges.
Oh, that's interesting. So the new generation of product's been specifically designed to actually overcome some of those challenges of working with OLED screens. So, I mean, we've had a really good summary of what you're doing and an overview of where the touch technology is used. I mean, could you, in a couple of words, just kind of sum up, where you think Microchip's strengths lie in touch? I mean, what is it you do really, really well that other people struggle with?
I think Microchip is really able to provide a very innovative and at the same time reliable touch solution. And combining these two aspects give the opportunity for our customer to design this very new and comfortable and intuitive interfaces that looks where the look and feel is great, without compromising on the comfort of usage and the reliability of usage. So the ability to support gloves, even if moisture is on the panel. And that's quite unique on the market.
And presumably, I mean, because systems are going to use other microchip components to build this interface, do you actually work with other business units or talk to them about what you can do? So maybe, for example, some of the microcontroller divisions can understand what's possible. I mean, is there some interaction like that internally?
Yeah, definitely. And that's quite important. There's also combining the touch functionality with haptic feedback is something that customers look at. And we have other business units like the APID business unit, which is proposing a high voltage driver IC that can drive piezo actuators. And actually, we're working together because we have some functionality in the maXTouch device that enables to control this high voltage driver directly from the maXTouch without having the need for any other MCU. So with this, you can build system with ultra low latency between the detection of the touch and the feedback of the vibration generated by the piezo.
So that's making it feel a lot more natural, presumably. You're not waiting to feel the feedback, and also presumably making it easier for the engineers to develop the system too.
Yes, clearly, because they will get all the product from one hand with extremely good performance in terms of latency, which is a key element when we talk about haptic feedback.
That's brilliant. One of the things I'm asking everybody, trying to learn a bit more about engineering during this podcast, is to ask about engineering advice. I'd love to know, Thomas, what the best bit of engineering advice you can give to the listeners would be.
Oh, that's a good question. Always make sure that they get the support of the expert to build it. So especially when you're starting with it, and we're always proposing solutions that try to simplify the design. But I think the aspect of technical support and development tool that are easy to understand are very important to consider when starting a design. So I will always recommend the engineer to try to get in contact with the expert for capacitive touch sensing.
That sounds like great advice. And again, I think this theme of making capacitive touch easier seems to run all through this. So I'm sure, getting in touch is going to, again, help people avoid some of those typical pitfalls. Thomas, it's been fascinating listening to you and learning a bit more about the world of touch sensing. If people are listening to this podcast and they'd like some more information, what would be the best way for them to get in contact with you?
Well, people can connect with me through LinkedIn. So Thomas Souche is my name, so Souche. Or go directly on our website and look at the product solution for maXTouch, or simply also directly type maxtouch.com on their browser.
That's brilliant. That's super easy. Thank you so much for being on the podcast, Thomas. I've really enjoyed this discussion.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.